everyone, and welcome back to my online teaching platform. We are still on how to determine the derivative of a given function. All right. In this video, we shall focus on explicit function. We shall focus on explicit function, and we'll be looking at how to find further derivatives or higher derivatives of given explicit functions. So in our previous videos, we learned how to find just the first derivative, which is the same as the dy dx or the y prime. All right. Now, there can be a situation where you'll be asked to find the second derivative or up to the third derivative of a given explicit function. So let us look at this. If you have a function, y is equal to 2x cubed. Y is equal to 2x cubed, and you have to find dy dx. You know that our dy dx will be equal to, you bring down the power, which is 3, and the 3 will multiply the given expression, which is a 2x, and you now reduce the power by 1. So it's going to be x having an exponent of 3 minus 1. And our dy dx will be equal to 6x squared. 6x squared. So this becomes our dy dx or our y prime. Now, you could see that our dy dx is now a function of x. Our dy dx is now a function of x. We're given y as a function of x, but we now have dy dx being a function of x. We can equally differentiate dy dx. So let us look at how best we can differentiate our dy dx. So we are going to find d dx of dy dx. So it means you have to find dy dx of your dy dx. So we are going to differentiate our dy dx again. But you could see that when you have dy dx, you can rewrite it as d dx multiplying y. Because the y here multiplies d dx, you are going to get dy dx. You are going to get our dy, sorry, you are going to get our dy dx. But here, the function that we have to differentiate is a function dy dx in terms of x. We are no more using the function y. We are going to differentiate our dy dx to get another derivative. So the second derivative becomes d dx of dy dx, meaning we are going to differentiate our dy dx. So we know our dy dx, to be 6x squared, but our dy dx is equal to 6x squared. All right. So we need to differentiate our dy dx again with respect to x. So we are going to get it as 12x. Now, it's not going to be dy dx again, but it's rather going to be the 2y dx squared, because when you have d dx of dy dx, this d will multiply the d over I, and we are going to get d squared. Okay, we are going to get d squared. And this multiplying this, we are differentiating the dy dx with respect to x again. So it means you are going to work on the x squared. It's going to be the x squared. So this x will multiply this x. So that will give us the x squared. So the answer becomes the 2y dx squared. So it means the x will multiply the x, and that will give us the x squared. Because when you have a term multiply itself, it's going to be the term having a power of 2. So the x times the x will give us the x squared. And here we have d times dy. We are going to get d squared y. So it is pronounced as the 2y dx squared. So our second derivative is 12x. So anytime you have a function and you have to find the 2y dx squared, it means you have to differentiate the function two times. You have to differentiate the function two times, which is the same as y prime prime. So it means you have to differentiate the function two times, which is also the same as f prime prime of x. So anytime you have these notations, it means you have to differentiate the function two times. So let us look at a situation where you need to differentiate the function three times. Suppose you have the 3y, then you have here to be the x cubed. Means we are going to differentiate the function three times, and this will be the same as y prime prime prime, be the same as f of prime 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 x. All right. So these are the notations for higher derivative. The 2y the x squared is for second derivative, meaning you have to differentiate the function two times. Then the 3y the x cubed means that you are going to differentiate the function three times. You have to differentiate the function how many times? Three times. All right. So we'll be learning how to find further derivative or higher derivative of functions in our subsequent videos. Thank you for watching. Please do not forget to subscribe to my YouTube channel, Maths with Ebefa. Bye.